Hey everyone, Mr. Voikin here. This is Unit 4, Lesson 1.1. We're going to take a look at inverse operations. So first on the left-hand side are the teacher examples, which I will go over, and then I will pause the video, allowing you to do the student examples on the right. So what are inverse operations? Well, first we have to know what the operations are, and the common ones for basic mathematics is going to be addition, subtraction, multiplication, division, and squaring a value. So inverse operations are the opposite operations. So the opposite of addition is going to be subtraction. So we have plus n, we're going to minus n, and that is going to leave us with a value of 0. And in the second example, when we're subtracting n, or we have a minus n, we want to add n, again resulting in a value of 0. Now for the third example, multiplication, the opposite is going to be to divide or division. So when we're multiplying by n, we want to divide by n. And this is actually going to leave us with a value of 1 because n divided by n is 1. Anything divided by itself is 1. The fourth example is division. So divide by n, we want to multiply by n, again resulting in a 1. Now the last one, n squared, what we want to end up with is a value of 1n. So to do that, we're going to take the n squared and we're going to take the square root of the n squared. And the square root of anything squared is just going to be itself. Now in this case, we wouldn't actually write 1n, we would just write n because we know that the 1 is assumed to be there. Okay, now let's take a look at some examples below and figure out how to apply this theory. So we want to make both sides equal. So that equal sign is going to be very important. It means that whatever's on the left has to be the same as whatever's on the right. And right now they are not the same. On the left we have an x, and on the right we have an x plus 7. But as we just learned, if I have a plus 7, I can minus 7, which is going to cancel those out, leaving us with just an x equals x. For the second one, I've got a g equals g minus 11. They're not the same, so I'm going to add 11 to this side, canceling out those 11s and leaving us again with a g equals g, the left equals the right. Okay, the third example says 7t, and when we see a coefficient or a number in front of a variable, they are multiplied together. So this is actually 7 times t, and the opposite of multiplication is going to be division. So I'm going to divide by 7. So 7 divided by 7 is going to be 1. So it's a value of 1t, which is what we're trying to accomplish, is find out the value of 1t or 1x or 1m. So in the last example where it says m divided by 3, this line right here means to divide. So m divided by 3, I want to do the inverse operation, which is to multiply by 3. So really what I'm left with again is a 3 divided by 3, which is going to give us that value of 1m. Okay, so on the right-hand side are some student examples. So please pause the video, complete that work, and then start it up again and check to see if you've done the correct work on the student examples. Okay, so here are the answers. Most of them should be fairly simple and straightforward, but take a look at this last one. And this one confuses students quite often because they see the negative sign there, and so then they want to add 12. But this is negative 12 times p, so we want to do the inverse operation of that multiplication, and I want to divide by, and not divide by 12, but divide by negative 12. Okay, in the last examples, we looked at some one-step equations, and we're now going to move on to two-step equations where we make both sides equal. So that means to end up with a value of 1x or 1t or 1m, we're going to need to perform two inverse operations. So you need to pay close attention to these different types of examples so that you know which operation to perform first. So in the first example here, I've got -6 plus x over 2. I want to deal with this -6 first. So I want to add 6 to both sides. That will eliminate those, and now we have x over 2 equals x over 2. Again, we want to end up with a value of 1x. So x over 2, we now need to perform one more operation. It's inverse, and this is x divided by 2, so I want to multiply by 2, and that will cancel both of those out, or really 2 divided by 2 equals 1, so I end up with a value of 1x. Okay, the next example right here, it says -4 times d minus 3. In the last example, you dealt with the addition and subtraction first, and then the multiplication and division. But as the d minus 3 is in brackets, we want to get rid of what's on the outside of the brackets first. And this is read as -4 times d minus 3, so we want to perform the opposite operation there, which is to divide by -4. Don't forget to include that negative sign with that 4. And those will, again, eliminate each other, leaving us with equal sides of d minus 3. But we want to end up with d. So because I have a -3 on that side, I'll perform the inverse operation of adding 3. And they cancel each other out. Woo! They cancel each other out, leaving me with d equals d. Okay, and the third example, it says that we have 9 plus n over 3, or 9 plus n divided by 3. And whenever we have a fraction, we always want to deal with whatever is on the bottom first. We want to get rid of that denominator. So as it's saying divided by 3, the inverse operation is going to be to multiply by 3. They will cancel each other out, leaving us with 9 plus n equals 9 plus n. Again, I don't want that 9 to be there because I just want to end up with an n. So in this case, I have a positive 9 on this side, so I'm going to subtract 9. They will cancel each other out, leaving us with n equals n. All right, and the final example says 11 minus 5n. Now, because they're both together there's no brackets, no denominator, we're going to deal with a 11 first. So whatever is not attached to that n in this case. And because it's a positive 11, I'm going to want to subtract 11 to cancel those. And that, oops, actually we wouldn't do it that way. Let's just see the way it's written right here. We would want to subtract 11 from this positive 11, canceling those two, leaving us with a negative 5n. Okay, and now both sides are equal. And if I have a negative 5n, what do I want to do? Well, this is negative 5 times n, so I want to divide by a negative 5, leaving us with a value of just n when these cancel. Okay, so just like we did before, there are 1, 2, 3, 4 student examples on the right-hand side for you to complete. Pause the video, and when you start it up again, you can take a look at the work that I did and compare your answers with mine. Okay, so hopefully you had some success. Take a look at the answers that I have here, and if you're having some problems, then we can look at it further during class. See you in class.